Good morning to all. Today we are going to see about some of the topics. The first one is coordination compounds. Generally, coordination compounds are chemical compounds that consist of anions or neutral molecules and that are bound to a central positive coordinate covalent bonds. And this is the way that is represent diagrammatic way. This is the way how we represent the coordination compounds. And next, it's classified into two types: double salts and coordination compounds. Double salts is formed by combination of two or more distinct salts. And these double salts are used in various applications, that is industries and including agriculture, etc. And they also show some of the characteristics. The characteristics are as follows. The first is stoichiometry, crystalline structure, distinct color, solubility, and separation. Stoichiometry refers to the ratio, and crystalline structure is the double salts contains well-defined crystalline structure, and distinct color. Double salts often possess unique colors due to presence of metal ions, and solubility is the solubility of double salts are differ from constituent salts, and separation. Double salts can be easily separated into constituent salts by appropriate techniques, that is by applying appropriate techniques. And next is differences. These are some of the differences between double salts and coordination compounds. First is composition. Double salt is formed by combination of two or distinct salts, and coordination compounds are formed by the central metal atom with ligand. Formation: it is a crystalline from a solution. It is a coordination of ligand from the central metal atom. Stoichiometry: it is a fixed stoichiometric ratio, and coordination compounds are variable coordination number and the ratio of ligands. Likewise, these are the differences between double salts and coordination compounds. And next is Werner's theory. Werner explained theory, that is he proposed a theory in 1898. The postulates of this theory are: the central metal atom in a coordination compound exhibit two types of valencies. They are named as primary valency and as secondary valencies. And these are some of the limitations of the Werner's theory. It fails to explain about magnetic, color, and optical properties, and it failed to explain the reason why all elements do not form the coordination compounds. And this theory does not explain about the stability of complexes. And this theory also did not explain about the nature of complexes. And applications, that is, coordination compounds are used in dye and pigment industries, and they are used in photographies, and they are useful in extraction of many metals from ores. And in biology, the main application is hemoglobin. In hemoglobin, it consists of a coordination compound Fe2 plus ion. And in vitamin B12 also, it consists of a tetraporphyrin, which is also one of the coordination compound. Likewise, in laboratory, nickel 2 plus is using as a complexing agent, that is dimethylglyoxamine. In medicine, cisplatin is used for treatment of cancer. In photography, developing of a film involves complex formation. In metallurgy, extraction of gold and silver. Whereas next, isomerism. Coordination compound exhibit two types of isomerism. One is stereo and next one is structural. Stereo isomerism compounds are same chemical formula but different spatial arrangements. And optical, and these are further classified into optical isomerism and geometrical isomerism. Optical isomerism is which is non-superimposable mirror image, and when the isomer, that is which rotates in a clockwise direction, is called as a dextrorotatory, where the plane polarized light rotates towards an anti-clockwise direction, is called as a levorotatory. And this is the example of the D isomer and L isomer. And next, geometrical isomer. It mainly observed in heterolytic complexes. They often have a coordination number 4 and 6. Geometrical isomerism also have a coordination number 4. And next, structural isomerism. They have same chemical formula but a different spatial arrangement of atoms. They are further divided into four types: linkage, coordination isomerism, ionization isomerism. Types of next topic is the types of chemical reaction. A chemical reaction is nothing but the bonds are broken within the reactant molecule and new bonds are formed within the product molecule to form a new substances. And next, this is the some of the items that consist of chemical reaction that is useful in our daily life: combustion, rusting, digestion process, photosynthesis. These are day-to-day activities. In day-to-day these activities, chemical reaction plays a vital role. And next, types of chemical reaction. Types of chemical reactions are classified into non-redox and redox. In non-redox, it consists of combination, double replacement, decomposition, whereas in redox, it consists of combination, single replacement, and decomposition. Combination reaction is nothing but combining of two or more reactant to form a single molecule. Here is, A plus B forms AB. And next, decomposition reaction. Decomposition reaction is nothing but a single compound breaks into two or more simpler compounds. That is, AB is a same compound and it's undergone reaction. It forms a product as A plus B. Displacement reaction, in which more reactive element displaces the less reactive element. Example, here they take zinc. Zinc react with copper sulfate, it gives zinc sulfate plus copper. And next, simple displacement or substitution reaction. This reaction is formed by one element is being replaced by another compound. Example, zinc reacts with hydrochloric acid, it gives zinc chloride plus elimination of hydrogen gas. Double displacement reaction is occur when a part of two ionic compounds exchange and makes to form a new component. That is, AB is one compound and CD is another compound. They both undergo reaction and they form AD plus CD. Neutralization reaction is acid and base react with each other and they form salt and water. Example, here they taken hydrochloric acid react with sodium hydroxide, it gives sodium chloride plus water. And precipitation reaction, it is nothing but two soluble salts in aqueous solutions are combined and form an insoluble precipitate. Example, silver nitrate react with potassium chloride, it gives silver chloride plus potassium nitrate. So therefore we have seen about coordination complexes. Coordination complexes are nothing but consist of an array of anions which are bound together to a central metal atom. And coordination compounds exhibit isomerism. Next, chemical reactions, these are classified into several types and chemical reactions are takes place in our day